This is task 7A from the electronics and control notes, in which we're asked to create the logic circuit from the truth table. And here we have a truth table with two inputs, and we know what the resulting output is based on these two inputs for this circuit. So we know A and B will be on the left-hand side of our diagram as inputs, and Z is our final output. The procedure we use to create the logic circuit from this table is to first of all identify all the rows in the table which have a 1 in the Z column. In this case, only this row here. We then write a Boolean expression for Z. So Z is equal to, in terms of A and B. Now, if we require A to not be 1, in this case, which is what we have here, then we put A with a bar across the top, say not A. So this means Z here is going to be 1 when A is 0. And the other condition needs to be met, put a dot for an and, B is 1. So we have B in its usual form. And that means that this expression tells us that Z will be 1 when A is 0 and B is 1. And that's the only condition we have here. So if we were to draw our circuit, our output up the other end has Z equal to A not and B. So not A and B. So this suggests to us that this output comes from an AND gate, because the dot in between the two letters tells us this is a product of an AND function. So we can draw an AND gate in here. We build this circuit up in reverse. What are our inputs for the AND gate? Everything that's separated by the dot. So we have not A on one side and B on the other side of the dot. So these must be our two inputs to the AND gate. And we can draw lines coming out of the AND gate here, like so. I'm just going to separate them slightly to allow us to draw on other things. So we know we have not A coming in this side, and we've got B coming in this side. Now over here at the beginning, we know our inputs are A and B. We know this because they are the headings in our table. And since we have B as one of the inputs to gate, it's just a matter of drawing a line connecting this gate all the way to B at the input. For A, we know we have A as an input. We've got not A going into this AND gate. So we need something that's going to transform A into not A, and that should be pretty clear what that is. We need a NOT gate. So we draw in the symbol for a NOT gate, and we have our connector that takes us to not A running to the gate, and on the left-hand side of the gate, our signal must be A. So A passes through the NOT gate to become not A. B comes straight from the supply. The not A and the B go into an AND gate together, giving us not A dot B, which is what we identified from our truth table to begin with. And that completes task 7, part A.